This video is on the Pythagorean Theorem. When you have a right triangle and you know the lengths of two sides, you can find the length of the third side using the Pythagorean Theorem. First, let's identify parts of the right triangle. The two sides adjacent to the right angle are called legs. The side across from the right angle is called the hypotenuse. The Pythagorean theorem states that if you take each leg and square them and add them together, you'll get the square of the hypotenuse. Now, that's kind of confusing to say, but the Pythagorean theorem is a squared plus b squared equals c squared. A and B are always the legs, the two sides adjacent to the right angle. C is always the hypotenuse, the side across from the right angle. Also, the hypotenuse is always the longest side. So if I know the two legs, let's say this leg is 4 and this leg is 5, then I do 4 squared plus 5 squared equals c squared. Solve the equation, we'll find the missing side. You may see the Pythagorean theorem written where they swap sides with the equal sign. C squared equals a squared plus b squared. Same thing. I like it like this. I like a squared plus b squared equals c squared. Two sides adjacent to the right angle are legs. The side across from the right angle is the hypotenuse, and the hypotenuse is always the longest of the three sides. Here we have a right triangle. It gives us the length of the two legs, 8 and 15. So I can find the length of the hypotenuse using the Pythagorean theorem. We take the two legs, 8 and 15, and we plug them in for A and B. It does not matter which one's A, it does not matter which one's B. You're going to add them together, and addition, it doesn't matter what order you add them in. Okay, order of operations, say I do my exponents before I add. So 8 squared is 64, 15 squared is 225. Then you add 64 plus 225 and get 289. Now to solve this equation, to isolate the c to get it by itself, I got to get rid of that square. So I've got to use the inverse operation. The inverse of squaring something is taking the square root of it. The square root of c squared is c. And the square root of 289, because I had to take the square root of both sides, is 17. So this side will be 8, this side will be 15, this side will be 17. 17 is the longest side, so that makes sense. So 17 millimeters is the length of my hypotenuse. Here's an example. I'm given a right triangle. I'm given the measurement of two legs, 8 inches and 9 inches. I'm asked to find the missing length. We'll call it X, which is my hypotenuse. It's my longest side. These are my legs, so I plug into my Pythagorean theorem, which is a squared plus b squared equals c squared. I plug 8 and 9 in for my legs. Then I follow order of operations. 8 squared is 64, 9 squared is 81. Add them together, you get 145. I have one more step to isolate the c. I got to get rid of this square, so I take the square root of both sides. The square root of c squared is c. Squares and square roots are inverses. And the square root of 145 is going to be just over 12 inches. So I'm going to round that to about 12 inches. And that's my answer, about 12 inches. Let's talk about how to use the square root button in a calculator. This is just a basic calculator that does have a square root button. That's also known as a radical sign. So once I added 64 plus 81, I got 145. All I had to do in this calculator is hit the square root button, and it gave me my answer, 12.04 and a bunch of numbers, and I rounded it to about 12. Here we're using a scientific calculator. It's a TI-30X-IIS. In order to do it on this one, my radical sign is right there. Actually, right here. So that's above the key. So it means I have to hit the second button first, pull up my radical sign, then I type in the 145, then I hit equals, and it gives me my answer. So a record calculator is actually easier for square roots, but a scientific calculator is easier for so many other things. Here's another example. I'm given a right triangle. My legs are 14 and 18, and I'm asked to find the hypotenuse. I have my Pythagorean theorem written out, a squared plus b squared equals c squared. I'm going to plug in 14 for one of my legs, 18 for the other leg. I'll use my calculator to find these measurements. 14 squared is 196. 18 squared is 324. When I add those together, I get 520. And when I take the square root of both sides, the square root of 520 is 22.8035085. Normally you round, and I'm going to use about equal to signs because I am going to round here. It's about 22.8, which is about 22.8 meters in this case, would be our answer. Okay, you try one. Try number one. And this will be a good one to have in your notes to look at when you do any others. Number one, your legs are 3 and 4. You find the hypotenuse. Okay, so you should have plugged in your two legs for A and B. Doesn't matter which one's A or which one's B. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. When I take the square root of both sides, the square root of c squared is c, and the square root of 25 is 5. So your answer is 5. Okay, try one more before we move on. Number 2 gives you the two legs of 48 and 20. Find the hypotenuse C. Plug the two legs in for A and B, doesn't matter which is which. $20 squared is 400. 48 squared, I need a calculator. Is 2304. Now just leave that in my calculator and I hit plus 400. And I get 2704. Take the square root of both sides. And the square root of 2704 is exactly 52. And since we were given feet, the answer is 52 feet. Now, it does make sense. C is 52. That's bigger than both of those. So my hypotenuse is the longest side, as was it here. 5 is longer than those. Let me tell you one more thing about this. Not only is your hypotenuse always your longest side, it's always less than the sum of your two legs. So let's look at this one first. My hypotenuse is 52. That's my longest side, but it's less than the sum of the two legs. 20 plus 48 is 68. So 52 is less than the sum, but it's greater than each one individually. Look over here. C5 is less than the sum of the two legs, which would be 7, but greater than either leg individually. The hypotenuse is always bigger than either leg individually, but less than the sum of the two. Okay, example 3 is the first one where we're given the hypotenuse and we have to find one of the legs. We still plug into the Pythagorean theorem. This time I'm given one of the legs, but I'm not given the other. And it doesn't matter if I plug 25 in for A or B. I just got to find the other leg. But it is important that I plug 40, the hypotenuse, in for C. So I take my calculator, 25 squared equals 625, bring down plus, bring down B squared, bring down equals. 40 squared is 1600. Now, before I isolate the B, I first have to get rid of this plus 625. So I subtract 625 from each side. Bring down the B squared. 1600 minus 625 is 975. Take the square root of both sides. Square root of 975 is 31.2249899. I'll round to the nearest tenth. I'm going to change this to about equal to 31.2. And I didn't use a unit of measurement, so 31.2 is fine. You try number 3, where you're given the hypotenuse 10, you're given one of the legs 8, you find the other leg. I've labeled it N, so you can let that be your A or your B, does not matter. All right, so I'm going to plug 8 in for one of them. It doesn't matter which one, so I'm going to leave my A square this time, and I'm going to plug 8 in for B and 10 in for C. Technically, I'm supposed to put that 8 and 10 in parentheses, but since I'm not using decimals or any hard numbers, it's okay if you don't. So A squared plus 8 squared is 64 equals 10 squared is 100. To get rid of plus 64, you subtract 64 from both sides. And 100 minus 64 is 36. And when you take the square root of both sides, the square root of 36 is 6. And again, I didn't use a unit of measurement, so we can just use 6. One more thing we need to talk about real quick is what's called the converse of the Pythagorean theorem. So if you're given all 3 sides of a triangle and you're trying to determine is it a right triangle, then it should fit into the Pythagorean theorem. So let's look at A. First of all, I know 6 and 8 are my legs and 10 is my hypotenuse because 10 is the biggest side and the biggest side is always your hypotenuse. So you plug them in and you work them out, you square everything, add them together, you get a true statement. If it's a true statement, then yes, this triangle is a right triangle. However, if you take the 3 sides and you plug them into the Pythagorean theorem, here I plugged 6 in for C because the hypotenuse is always your longest side. So 4 and 5 had to be my legs. I square everything, I add them together, I get a false statement. So that triangle is not a right triangle. If you plug them into Pythagorean theorem and get a true statement, it's a right triangle. If you get a false statement, it's not a right triangle. And when you do this, you have to remember the biggest number, the biggest side, the longest side is always your hypotenuse. And that's the converse of the Pythagorean theorem. So in review, the legs are the 2 sides adjacent to the right angle. The hypotenuse is the side across from the right angle. And this only works with right triangles. The Pythagorean theorem states that the hypotenuse squared equals the sum of the legs squared, or A squared plus B squared equals C squared. And remember, they have it written backwards here. But I like A squared plus B squared equals C squared. The starburst video, which I should have already showed you, is what this is saying right here. And also, there are some groups of numbers that you don't even have to use the Pythagorean theorem to figure out. They're called Pythagorean triples. Here are some of those Pythagorean triples. 3, 4, 5, 5, 12, 13. These are all right triangles. I've actually used this one twice already. We did a 3 and a 4 leg and found the hypotenuse of 5. I knew it would be a nice even number and not an irrational decimal because I knew it was a Pythagorean triple. Then I gave you a 6, 8, 10 one. I gave you 10 for the hypotenuse, 8 for one of the legs, and you had to find 6 the other legs because 6, 8, 10 is just multiplying these numbers by 2. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So if 3, 4, 5 is a triple, so 6, 8, 10. Or I could multiply them all by 3 and get 9, 12, 15. Or I could multiply them all by 5 and get 15, 20, 25. Or I can multiply them all by 10, which is what the football video that you should have already seen did. It multiplied them all by 10 and got a 30, 40, 50. That is a Pythagorean triple. If you memorize Pythagorean triples or any multiple thereof, and you see one of these, you don't even have to use the Pythagorean theorem to get your answer. And I'm going to show you a video to help you remember these Pythagorean triples as well. Okay, let's look at this practice problem. I noticed they give me the 2 legs. I'm supposed to find the hypotenuse. First of all, I know 7, 24, 25 is a Pythagorean triple. So I know the answer is 25. But if we had to work it out, let's see what they do here. So we got to plug in for A and B. And again, they wrote it backwards. They put C on the left side. I like it on the right. So I got to remember, here's my 2 legs. I'm going to plug 7 and 24 in there. You got to square both of them. Then you got to add them together. Then you take the square root of both sides, and you do, in fact, get 25. On this problem, you're given a leg and a hypotenuse, and you have to find the other leg. This is not a triple, so I would have to use a Pythagorean theorem. C is going to be 12. It's the side across from my right angle. My legs are 4 and an unknown, so they plug 4 in for A. The unknown they put as B. And again, they put their C on the left side. I like it on the right, but it doesn't matter. 4 squared is 16. 12 squared is 144. Subtract 16 from both sides. Then take the square root of both sides. And you would get your answer, which in this case, since it's not a Pythagorean triple, it's an irrational number, which they rounded to the nearest hundredth, 11.31. And let's look at one converse of the Pythagorean theorem, where you plug all 3 numbers into the Pythagorean theorem, and if it gets a true statement, it is a right triangle. If it's a false statement, it's not a right triangle. By the way, I know this is a right triangle because this is a Pythagorean triple. 3, 4, 5, all times 2 are 6, 8, 10. This is a triple, so I know it's going to be true. But if we didn't know, we'd have to plug 6 and 8 in for A and B, 10 because it's the longest side in for C. Square everything, then add your 2 like terms together, and you would get a true statement. So the answer is yes, this is a right triangle. Thank you.